Hi, this is Mr. Van Scoy. We're kicking off our unit about the importance that oceans and our Great Lakes have on climate patterns. The ocean covers more than 70% of the Earth's surface, so it shouldn't come as a surprise then that the ocean plays a major role in regulating the weather and climate of the planet. We'll also take a look at our own special body of water, the Great Lakes, as we live in Michigan. It's kind of a big deal, both literally and for us that live here. A big deal. So we'll use our first lesson to kind of as a quick introduction to weather and climate. When you are done with this lesson, you should be able to explain the difference between weather and climate. You should also be able to identify factors that impact weather and climate. All right, first up is weather. Weather is the air temperature, cloud cover, precipitation, wind, moisture content or humidity, and air pressure at a particular time in a particular location. And you can see here some images for our home state of Michigan. It reflects the current conditions of air masses over both the land and sea for our entire globe. Climate, on the other hand, is the overall picture of weather during periods of seasons or years. Climate is the weather in a location averaged over a long period of time. An old saying goes, climate is what you expect, weather is what you get. The Earth's main energy source is the sun. The sun causes convection within the atmosphere. Convection is that movement of a fluid due to differences in temperature. In this case, we're talking about the atmosphere, or the air, and the moisture that goes along with it. So it's the movement of a fluid due to differences in temperature, and it can create even convection cells, which is a pattern or a circular pattern of warm air rising, and then as it cools, starting to sink. This in turn affects the weather and the climate. This convection produces winds and ocean currents. The greater the pressure differences between a low pressure area and a high pressure area, the stronger the winds. So if there's less of a difference, then that wind would be more gentle or weaker. In another lesson, we'll actually take a look at surface and ocean currents in more detail. Again, remember that temperature, air pressure, wind patterns, and ocean currents are all going to be major parts of climate. Winds and ocean currents influence many parts of the climate. Again, examples being air temperature, humidity, wind speed and direction, the type, quantity, frequency of precipitation. Next, we're going to be taking a look at factors that actually determine a location's climate. And for these next few sections, I have them broken up in kind of some subsections. So the first one here, we're going to take a look at how a region's position on the globe and on a continent determines its basic or fundamental climate. I don't really have much else to say about that one, so we'll move right along here to about how latitude determines a location's solar radiation and the location within wind belts. So around the globe there are different wind patterns that go from east to west. Those are called the easterlies. And you can see those here at the poles and here in those low latitudes. And then there are also patterns, and you'll find those same patterns down here in the southern hemisphere. There are also wind patterns that go from west to east. And those are called the westerlies. By the way, you always name winds from where they come from. So westerlies are winds that generally come from the west. There are also convection patterns moving north to south and from south to north. So these patterns here. And those actually create convection cells. We also talked about how latitude affects the solar radiation. So for example, the equator receives the most solar radiation. It's the most consistent in temperature. There are temperature changes, but it's the most consistent amount of solar radiation. Days are equally long almost year-round. And then on the other extreme we have polar zones. In the polar areas, they're going to receive the least amount of radiation, and you're going to have more extreme days and night. Also there, in the polar regions, light's going to be filtered as it's traveling through more atmosphere and at an angle. And you also have a higher reflectivity where the ice caps are actually reflecting more solar radiation back into space. So as mentioned, there is a higher reflectivity at the poles than at the equator. Actually, the nice fancy science term for that is albedo. At the poles, I'd mentioned there were glaciers there, and that light, when it comes in, it hits that lighter objects like ice. It's going to reflect most of that back into space. When the glaciers are gone, like in the summertime for the North Pole, it's going to come in and hit that water, which is darker, and more of that is going to be absorbed. Less of it is going to be reflected back into space. So the albedo changes throughout the year. Mountain ranges also have an effect on weather and climate. Mountain ranges separate land areas from the ocean, and they also create what are called a rain shadow effect. Air pressure and temperature decrease with altitude. So I'll go into a little more detail about how mountains impact climate. So the air pressure and air temperature decrease with altitude. That is the height above sea level. The closer the molecules are packed together, the more likely they are to collide. Collisions between molecules give off heat, which warms the air. At these higher altitudes, the air is less dense and the air molecules are more spread out and therefore less likely to collide. So a location in the mountains has a lower average temperature than one at the base of the mountain. So higher altitudes mean less dense air, less likely to collide, and lower average temperatures than there would otherwise be at the base. The other thing it does is creates what's called a rain shadow. So as that air is rising, the warm, moist air is forced up to rise over those high areas. The air cools. As it cools, it starts to condense because the air can't hold on to that water vapor anymore. It forms clouds. And if that continues to rise, it'll actually start raining. So then, as that air starts coming back down the other side of the mountain, it creates what's called a rain shadow or a rain shadow effect, where it's actually quite a bit different amounts of precipitation on the leeward side than there is on the windward side of a mountain. Mountains also separate regions into maritime, that would be the oceanic air masses. Those are going to be on the windward side of a mountain, and separates them into a continental air masses, which are going to be on the leeward side of the mountain. Here I've got a very simple table. This table shows the average trends for a maritime climate and continental climate. So these are just trends. And maritime climates, they tend to be slightly cooler on average, and they tend to have more moisture. On the continental or in continental air masses, temperatures tend to be a little bit warmer. They're more extreme. You have colder colds, but then you have hotter hots. And there, again, tends to be less moisture because most of it has been dumped on the windward side of that mountain. And the other topic that I'll just mention now is that if a region is near a large body of water, its climate will be influenced by that water body. So more on that later. I'm about out of time, and that's actually going to be something we're going to dive into a lot more in the rest of this unit. So now you should be able to explain the difference between weather and climate, and you should be able to identify some factors that impact weather and climate.